Okay, today what we're going to look at is exercise 904. So exercise 904 is talking about the length of an interval. So an interval is a line that is between 2 points. So what we're going to do is we're going to use Pythagoras' theorem to find the length of the following intervals, and we're leaving our answer as a surd, so in the square root form where necessary. So it's important to know that Pythagoras' theorem is c squared equals a squared plus b squared. Now, the questions that you guys are meant to do is A, C, E. So I'm not going to do A, C, or E. I'm going to do B to just go through how to do it, and then you can have a go at A, C, E for question 1 yourself. So for question 1, B, so we're using Pythagoras' theorem, and what we want to do is we will note that we have that this side is 3, this side is 4, and we're trying to find this length here. So what we do is we label the sides of our triangle, and so C is always opposite our right angle, and then our other two lengths are A and B. So using Pythagoras' theorem, which is c squared equals a squared plus b squared, we're going to substitute in these values for A and B. So A is 3, so it'll be 3 squared, plus our b squared is 4 squared. So then we have c squared equals 3 squared, which is 3 times 3, which is 9, plus 4 squared, which is 4 times 4, which is 16. So we have c squared equals 9 plus 16 is 25. And then what we want to do is we're trying to find the length c, not the length c squared. So we want to square root both sides. And when we square root c squared, we just get c. And then we have the square root of 25. And we know that the square root of 25 is 5. So our distance is 5. Going to question 2, we want to find the lengths of BC and AC. So if we just look at 2A, BC is the length here, AC is the length here, and then we want to use that to find the length of AB, and then we can leave our answers in surd form. So again, you're doing A, C, E, G, and I in this question. So I'm going to do B for you to go through it. So question 2B, what we need to do is we need to find the length of AC and BC. So AC has length 1, 2, 3. So AC equals 3, and I'm going to write that on my diagram. And then we have to find BC. Now BC has length 1, 2, 3. And so that's a 3. And then we want to find AB. So that is what we're going to find, and we're going to use Pythagoras' theorem again, where our side opposite our right angle is our C, and then our other two sides are our A and B. So for Pythagoras' theorem, it is c squared equals a squared plus b squared, and then I'm going to substitute in my a and my b value. So we have c squared equals 3 squared plus 3 squared. So c squared equals 3 squared is 3 times 3, which is 9, plus 3 squared is 9. So we have c squared equals 18, and we want to square root both sides, so we get the square root of 18 as our final answer. So that means that we have found that the length of AB is root 18. Moving on to question 3, we want to use Pythagoras' theorem to find the length of interval AB in each of the following. So we're trying to find this distance here, and we want to use Pythagoras' theorem like so. So I'm going to do B again for you, because if we go back, you have to do A, C, E, G, and I. So that's lots of fun. So question 3. So we want to draw a right angle triangle here in order to work out our distance of our other sides and to use Pythagoras' theorem. So I'm going to draw my right angle triangle like so. A little bit wonky, but that's okay. And what we want to do is we want to find the distance of both sides of our right angle triangle. I'm just going to put a right angle in there. So the distances are, the distance of our horizontal is 1, 2, 3. And the distance of our vertical is 1, 2, 3, 4, 5, 6, 7. So then we want to label the sides of our triangle with our C, A, and B. So remember, our C is always our side that we're finding, which is opposite our right angle. We have our A and we have our B are just our other sides. Now you can label this side B and this side A. It doesn't matter which side you label which. So Pythagoras' theorem is C squared equals A squared plus B squared. So we'll have C squared equals our A value of 7 squared plus our B value of 3 squared. So C squared equals 7 squared, which is 7 times 7, which is 49, plus 3 squared, which is 3 times 3, which is 9. So C squared equals 49 plus 9, which is 58. And so then what we do is we take the square root of both sides. And so what we get is we get that C equals root 58 as our answer. For question 4, we want to find the distance AB for each of the following and leave our answers in third form. So we've just been given some points. So what I would suggest to do, it would be to draw up a number plane yourself. So I'm just going to draw one over here. Okay, and I'm going to plot these points. So I'm going to plot the point -2, 0. So I need some numbers on my number plane. That would be helpful. 2, 3, 4. Okay, so that's 1, 2, 3, 4. -1, -2, -4. 1, 2, 3, 4. -1, -2, -3, -4. So see how quick and easy it is to draw up a number plane? So I'm going to plot my points. So -2, 0. So we start at the origin, we go across to -2 for our x, and then for our y it's 0. So we just stay there. So that's our first point. And then our second point is 2, 4. And so we start at the origin, we go across 2 in our x, and then up 4 in our y. So it will be the point here. And so what that means is I want to find this interval here. I might actually do that in a different color because, you know, like so. So that is what we're trying to find, this interval. So what we then want to do is, using this interval, we want to draw a right angle triangle. So, like so. And then we want to find the distance of each. So the distance will be of our horizontal is 1, 2, 3, 4. Let's just add some more colors in here. So that's a distance of 4. Well, that's a bit thick. And then our distance of our vertical is 1, 2, 3, 4. Okay, so now we want to label our triangle with our, look, I'm just trying to work out what color to use next, with our C, A, and B. So remember, our C is always opposite our right angle, and then we have our A and our B value, and then we want to plug this in to our Pythagoras' theorem, which is C squared equals A squared plus B squared. So when we plug that in, we'll get C squared equals, our A value is 4 plus our B value is 4. So C squared equals 4 times 4 is 16, plus 4 times 4 is 16. So C squared equals 16 plus 16, which equals 32. We then take the square root of both sides, so we get the square root of 32, and we're going to leave it as the square root of 32 because if we put it into our calculator,